Hi Year 11. So what I want to have a look at in this video is proving some key identities. We actually had a little bit of a go at this earlier on and in a little bit in the combinatorics exercise, or I worked them and a couple of you in class did. So it's just basically looking at proofs in terms of NCR, and we remember that NCR is n factorial on r factorial n minus r factorial. If you forget that, that one's actually written on your HSC formula sheet. Now, I'm not going to prove these first two proofs here because they're in your booklet and you can pause the video and they're fairly straightforward. They're just replacing the n and the r into the formula and making one side equal the other side. So basically, when we're looking at proofs, what we're going to do is we're going to start with the left-hand side and we're going to write down what the left-hand side is. So in this case, in this proof, we're wanting to prove that this is the case. So we're going to start with our left-hand side, which is NC0, and we're going to work through and try and get to the right-hand side. And that's generally how we do a proof, unless we get into mathematical induction, which is slightly different. And we can do the same with the NCN. So they're fairly straightforward. The other way to do a proof is to work the left-hand side down as far as you can go, work the right-hand side down as far as you go, and get those two sides to be equal. I'd like to, on the video, work through some of the some of the harder proofs. And this one here is a little bit harder. So let's have a look at working through NCR equals NCN minus R. And this would be one where we're going to work the left-hand side as far as we can get, and then work the right-hand side as far as we can get, and get those two sides to be equal. So if we look at the left-hand side of the proof, the left-hand side is NCR. And we can write that down as n factorial over r factorial n minus r factorial. I don't want to expand that out any further. We want to go to the right-hand side, which is NCN minus r. So here we've written what the right-hand side is equal to. Let's make a little note here of that NCR is n factorial and n minus r factorial. And we're trying to prove, what have we got? Sorry, I should zoom in here. What NCN minus r is. Okay, so NCN minus r into this format over here is, the top line is going to be n factorial. The bottom here is our r factorial from over here, which is n minus r factorial. And the other one in the brackets is normally the top minus the bottom. So we've got the top minus the bottom. So it's n minus r. If we simplify that, we get n factorial staying on the top. The n minus r stays on the bottom. And the n minus r becomes n minus n, which is nothing, minus r, which is r. So we end up with just r factorial, which is exactly the same if we rewrite it like this, like our other left-hand side. Okay, so we're going to now work through this one over here. So we're going to work through NCR equals n minus 1 CR minus 1 plus n minus 1 CR. And that's going to be values of r between 1 and n minus 1. Okay, so we need to prove that the left-hand side is equal to the right-hand side. But it's going to be hard to manipulate NCR into this right-hand side. So what I'm basically going to do is I'm going to write it like this and basically move that stuff from there to the other side. So I want to prove that this is equal to this, and that's going to be a little bit easier if we can manipulate it that way. So we're going to remember that NCR is n factorial on n minus r factorial, r factorial, and we're going to work each of these into this format. So if you want to pause the video and see if you can do that, that's what we're going to do now. So my left-hand side is equal to n minus 1 CR minus 1 plus n minus 1 CR, which is equal to, so I'm going to expand this part here, which becomes n minus 1 factorial all over r minus 1 factorial n minus 1 minus r minus 1 factorial. So I've just input these as I would have up here for my n and my r. Okay, that's going to be plus. Let's organise the second one here, which will be n minus 1 factorial on the top line. It will then be r factorial on the bottom, multiplied by n minus 1 minus r factorial. Now I'm just going to neaten that up. Most of the time these fall out with just algebra manipulation. Sometimes the algebra gets a little bit tricky, but we're extension 1 now, so we've just got to keep going and think of all the little skills that we've learned along the way. So here I've got n, well, let's just do it the long way, n minus 1 minus r plus 1 factorial, and the other side is going to stay as it is. And you might want to have done this all in one step. So I'm basically just going to neaten this part up in here. Okay, so this is n minus 1 factorial on the top, r minus 1 factorial, and in these brackets the ones cancel out to be 0, and I've got n minus r in the brackets factorial, and my right hand side stays the same. Now, oops, sorry if you can hear children in the background yelling out. Okay, now let's have a look at what we've got. So what we want to do now is get these over a common denominator. So have we got anything common on the bottom that anything goes into? Well, we probably do, but I'm thinking the easiest way is going to be to, in this case, just to multiply everything out and see what we can do. Actually, I take that back. I'm going to do it simpler. Sometimes we're thinking on the run here. Now, if we think of what we've got, and I'll just get the highlighter, think back to our combinatorics chapter and think what our r factorial is. If I write that over here, we could also write r factorial would be the same as writing, remember it's r times r minus 1, r minus 2, r minus 3, etc. So it's also the same as writing r, and I've got r minus 1 factorial. So I've pulled out the r, but I'm still going to move down by 1 from my r minus 1. So I can write it as r minus 1 factorial. So if I was to do that and I replace my r here with, well, let's write it back out again. Again, we're doing it slow so you get the hang of this sort of thing. And I've also rewritten my n minus 1 minus r as n minus r minus 1. So if we think what n minus r factorial is, let's put this as a little aside, n minus r factorial is actually n minus r times n minus r minus 1 factorial. So I'm going to fix that one up as well, and I might just rub that straight out and pop that in there as n minus r, oops, times n minus r minus 1 factorial. And the reason I've done that now is our bottom line can be made up of the terms. We won't do it as two parts. What are we going to have? We're going to have r times r minus 1 factorial times n minus r times n minus r minus 1. So that's the smallest number that both of these are going to go into. If we had done it the way I was originally going to do it and multiplying everything out, it would have been quite a mess. So let's have a look. We're dividing this term here into this one here. And what are we going to have? We're going to have an r. So it's going to be r times that top line. And we'll have that same bottom line written over here for the other one. So r minus 1 factorial, n minus r minus 1. I want to divide this into here, or what do I do to turn this into this? I'm going to times by n minus r. I've already got an n minus 1 factorial, and I'm going to times it by n minus r. So let's pop that all over one denominator, and you could have done it in the one step. We're going to have r minus 1 factorial, n minus r minus 1, and our top line will become r times n minus 1 factorial plus n minus 1 factorial n minus r. Okay, now remember what our aim is. We need to go another step. I'm going to factorize out of the top line n minus r factorial. So let's write our top line as n minus 1 factorial times r plus n minus r. And our bottom line becomes r, well, is the same as we had before. So what we're going to have up here is this r and this r are going to cancel. So we're going to end up with an n times n minus 1 factorial all over r times r minus 1 factorial n minus r minus 1. We can neaten this up a little bit more. I've just gone back and actually forgotten this see the factorials over there? I've forgotten those, so I'm just going back to fix that up. So I've forgotten those off there. So that's a very silly mistake on my behalf. You can see how easy that is. Now remember, our original aim is to get all of this to be equal to NCR. And what was NCR? N factorial and n minus r factorial. So at this point you might be thinking, oh, it doesn't, but how are we going to get there? Let's have a look. So we want it to be equal to n factorial on n minus r factorial, because that's our NCR. So at this point, some of you will go and think, no, I can't do it. But you can, because look at the top line. N times n minus 1 factorial. Well, n is just the term before, n minus 1 factorial. So I can write my top line as n factorial. And my bottom line, well, r times r minus 1 factorial is r factorial. And n minus 1, my computer's doing silly things, times n minus 1 factorial is n minus r factorial, which is actually equal to NCR, which is our right-hand side, which is what we wanted. So that one's very long-winded, but I want you to have a go at doing that yourself, and there's more of those to have a go at.